Chapter 5, Section 3, Data Transformation. Let's go on to another major component of data preprocessing, data transformation. Data transformation is to transform and combine multiple variables to make the dataset easier for analysis. Data transformation refers to operations for making the dataset easier for analysis by transforming or combining multiple variables. Data transformation includes transforming a numerical variable into categories, transforming categories into numbers, transforming categories into dummy variables, and creating a new variable from multiple variables. This is not a comprehensive list, and covering all kinds of data transformation is beyond the scope of this course. These are just popular examples. Let me explain these examples. The first example is transforming a numerical variable into categories. In descriptive analytics for a reporting summary, we often analyze data by categories. Such categorical analysis is easy to compare data by categories. We can transform a numerical variable into categories by setting boundaries between categories and classify the numerical variables. For example, we can classify people into age group by 10 years of age. We can also classify people into binary age categories such as high and low. The second example is the opposite of the first example, transforming categories into numbers. When we develop a causal or a prediction model, usually, variables included in the model should be quantitative ones. Some qualitative variables can be transformed into correspondent values, but many of qualitative variables cannot. So, as a second best, we can convert them into approximate numerical values. For example, when we have age group data, classifying observations with 10-year range, we cannot use it as a quantitative variables because a range is not a specific value. In such cases, we can use a representative value of each group. Specifically, we can convert the range to a class value, which is the median of the range. We can calculate a class value by dividing the sum of the minimum and the maximum value of the range by 2. Let's see another example. We often use this kind of qualitative ordinal scale in a questionnaire. But each of them is not a number, so we cannot use them as quantitative data. In such cases, we assign corresponding values to represent the order assumed in the qualitative scale. In this case, we can assign 5 to very satisfied, 4 to satisfied, and so on. We should know that the converted data can be regarded as ordinal, but it cannot be regarded as ratio data. So, in this example, arithmetic operations using these values are meaningless. For example, if we divide 3 by 5, we get a value of 0.6, but it is meaningless. It is because this 3 is not 3, but neutral, and the 5 is not 5, but very satisfied. We cannot say neutral is 60% of very satisfied, so here we cannot divide 3 by 5. The third example is transforming categories into dummy variables. Dummy variables are variables that indicate categories by 0 and 1. Dummy variables are often used in causal analysis and prediction analysis. So, we will give detailed explanation of dummy variables in later chapters. Here, let me give you just a brief explanation. Let's see what a dummy variable is by examples. Suppose we have data of gender, and suppose it consists of only male and female. In this case, if we want to use gender as a quantitative data, we can assign 0 to male and 1 to female. We can assign 0 to female and 1 to male, whichever is okay. By doing so, we can convert gender into quantitative data. But how should we do if we have 3 or more categories? Suppose gender data consists of 3 categories: male, female, and others. There's no order in these categories, so we cannot allocate them ordinal number like 1, 2, and 3. In this case, we need to select one category as a reference group. Usually, we select the largest categories as a reference group. Then, create new variables which represent the category except for the reference group. Here, suppose the reference group is male, so we need to create 2 variables, gender female and gender others. For the variable gender female, when the person is female, the value is 1. Otherwise, the value is 0. Similarly, for the variable gender others, when the person gender type is not male nor female, the value is 1. Otherwise, the value is 0. Here, the newly created 2 variables are dummy variables. So, if the person gender is male, both the dummy variables are 0. If the person's gender is female, the variable gender female is 1, and gender others is 0. If the person's gender is not male nor female, the variable gender others is 1, and gender female is 0. In this way, we can express 3 categories with 2 numerical variables. The fourth example is creating a new variable from arithmetic operations using existing multiple variables. For example, if we have profit data for the first, second, third, and fourth quarter, we can obtain data for yearly profit by summing up the profits of those quarters. And if we have data of the year's sales amount, we can obtain data of profit rate of the year by dividing profit by sales for the year. As another example, suppose we have 4-item 5-point scale data of work motivation. In such cases, we can compute the average of scores of these 4 items and use it as an overall level of work motivation. By doing so, we convert 5-point scale into a nearly continuous variable. Thank you for watching. Please thumbs up and subscribe to my channel.